All right, good morning. So today we're going to take a look at adding and subtracting radical expressions. So for number one, I have 2 square roots of 5 plus 4 square roots of 5. So let's kind of change this problem for a second. Let's look at it a different way. So let's pretend for a minute we have 2x plus 4x. That would give me 6x. So when we add these two radical expressions, it's going to work mainly the same way. So let's go ahead and get rid of these. And let's go ahead and add the two actual expressions now. So I have 2 square roots of 5 plus 4 square roots of 5. So all I'm going to do is I'm going to add together the coefficients. 2 plus 4 gives me 6, and I'm going to leave the radical alone just like I did to the x. So I had 2 square roots of 5, I had 4 square roots of 5, I put them together and got a total of 6 square roots of 5. And you'll notice with number 1, both radicals were the same. I had square root of 5 in both of them. So whenever I take a look at number 2, it's going to be a little bit different. So in number 2, I have a square root of 7, I have another square root of 7, then I have that root 3. So what I'm going to do is I'm going to combine like terms. So I have 6 square roots of 7, I have negative 2 square roots of 7, 6 minus 2 gives me 4, 4. So I have 4 square roots of 7. And I still have that 3 root 3 left over. So in my answer, I'm just going to bring it down, 3 square roots of 3. So I have 4 square roots of 7 plus 3 square roots of 3. They're not like terms, so I can't put them together, so it just stays 4 root 7 plus 3 root 3. Okay, moving on to number 3. Now if I look at that one, they're both totally different. I have a square root of 24 and I have a square root of 54. Now the difference between number 3 and the difference between that and numbers 1 and 2, if you look at the ones in numbers 1 and 2, the radicals were all prime. I had a 5, I had a 7, I had a 3. None of those broke down. So what I'm going to do with number 3, the first thing I'm going to do is I'm going to break down the two radicals with factor trees because I can simplify those. And hopefully they give me radicals that can be subtracted. So 24, I have 3 times 8. And then 54, I have 2 times 27. 3 is prime, 8's not, so I'm going to continue to break down 8. So I have 2 and 4. 4 is 2 and 2. So if I look, I have a pair of 2's. I have a 3 and a 2 left over. And don't forget about this 6 that was already on the outside of the radical. So on the outside of my radical, I have a 6. Now I have a 2. And then on the inside, I have a 3 and a 2. 3 times 2 is 6. So that gives me 12 square roots of 6. The other one, I already broke down 54 and a 2 and 27. 27 is 3 and 9. 9 is 3 and 3. So I have a pair of 3's. And then I have this 2 and 3 left over, just like the other one. So minus, I already have the 5. Now I have a 3. Square root of 2 times 3 is 6. So minus 15 square roots of 6. And then I put those two together. 12 minus 15 is negative 3 square roots of 6. And if you got two radicals that would still be different, then you just can't combine them. It would look a lot like number 2. All right, moving on. Now I want to talk about one that has a variable in it. So in number 4, we're going to break the radicals down with our factor trees just like we did in number 3. So I have 3 and 9. 9 is 3 and 3. I have this pair of 3's, 3 left over. So I got to bring down my 2. So I have 2 times 3 and then square root of 3, which gives me 6 square roots of 3. Plus 75 is 3 and 25. 25 is 5 and 5. So I have a pair of 5's, and then I have this 3 left over. There's a 1 on the outside of the radical, so I don't need to include that because 1 times 5 is just going to be 5. So 5 moves to the outside, 3 stays on the inside. And then the last one, I have 12, which is 3 and 4. 4 is 2 and 2. And then I have a pair of 2's with 3 left over. So plus, the 5 comes down. Now we have a 2. And then I have a square root of 3. Now the one thing I haven't touched on yet are these x's. They all have exactly one x, which means there are no pairs. So my x is just going to stay inside my radical. And then let's clean this up a little bit. So we already said we have 6 square roots of 3. This one's already simplified, so I have 5 square roots of 3x. And I forgot my x here. So we have 5 square roots of 3x plus 5 times 2 is 10 square roots of 3x. Now we have all additions, so we're just going to add up those coefficients. 6 plus 5 is 11. 11 plus 10 is 21. So I have 21 square roots of, and we leave the radical alone, so we just get the square root of 3x.